In our lesson using interaction diagram charts, we learned about a particular variable called gamma. And gamma is the percentage of h, which describes the center-to-center distance of the outermost bars in a concrete column cross-section about the axis of bending. And so if we have some bars here and here on our cross-section, and we have an overall dimension for our column of h, this center to center distance is equal to gamma h. There are some rules that kind of give you some guidelines for what to do under various conditions. For example, if the gamma that you end up calculating when you check your gamma value to see if it is okay with respect to your estimated or your initial guessed gamma, if you find that your actual gamma is less than the estimated gamma, then you will probably have to either try a smaller gamma and use a different interaction diagram chart, or you may choose to use a bigger column. The other thing that you can find is that if the needed gamma turns out to be less than 0.6, that too is a situation where you will probably have to choose a bigger column cross-section size. The other thing that can happen is that based on your choice of gamma, it might be that your rho g value is much less than 0.01. And if it is much less than 0.01, then that would be an indication that your column is probably too big. And so then you might be able to use do a more efficient use of material by using a smaller column. And we also have the possibility that rho g is greater than 0.08. This is saying that you need a lot of steel in the cross-section that you chose. In fact, so much steel that you're exceeding the maximum rho g that the code prescribes. Now, when you have that much steel that you're needing to have, there are two things that you need to think about. One, you're probably not even going to be able to get that much steel in the concrete column cross-section and satisfy all of the ACI code requirements. And when this happens, it's also an indication that indeed you really should try a bigger column cross-section, or you might try a bigger value of gamma if that is even possible. So those are some things to consider when using the interaction diagram charts. The other thing that you can do when designing columns, at least in this setting in school, is you can check your work by going to the network drive, and you can go to K class ENGR 442 and go to the folder called column, and there is this executable file here called column.exe, and that is a computer program that I have written that will look like the following. When you run that program, you will have a computer screen that looks like this, and you have the ability to provide input such as the geometry. This is similar to the reinforced concrete beam program that you have used in the past. You can specify the number of layers of steel. You can put in the area of steel at each layer and their distances from the topmost edge of concrete in compression. And when you have entered all of those in, which I have done here, and I have done this for the example column that we designed. And you'll notice that even though the topmost layer has 6 bars on one face, I've added up all 6 bars area and I get 2.64 inches squared, and that is at that distance of 2.25 from the uppermost face. And then the next layer has well, I put 0.44 here, and actually that's a mistake. It really should have been 2 number 6 bars, but that's the next layer at that level. And for each of these levels, I have put in the area and its distance. So all of these 0.44 values really should have been 0.88. And then I have the last layer, which has 6 bars. And so we get 2.64 square inches. Well, once I have put all that information in, and I've also put in my cross-section dimensions, and over here I have ignored flanges, so I have not enabled flanges, so that case has not been considered here, then I can say that I'm done, and it will calculate and draw this interaction diagram. The other thing that you'd want to check is also the material properties, and I have, of course, the modulus, I have the yield stress for steel, I have the compressive stress for concrete, and epsilon sub u, and those are correct for our case that we have been considering. And in addition to this interaction diagram, it also draws the cross-section here, and it just draws a single bar, even though there are a bunch of bars at this level. And then there are just 2 bars here, and so you can kind of see that you have put your bars in the correct location. The other thing that we can do is we can go to input here, and we can put in our design loads. And if you consider in our problem, we actually had 1500 for P sub u. That was 1500 kips. And we also had, well, I'm forgetting right now. So I'm going to go and I'm going to find what M sub u was. If we look at our example, in our given problem, it had a P sub u of 1500 kips and M sub u of 400 kip feet. So then I'm going to go to my program here and put in 400 for MU. And when I'm done with that, you can see it's put a little dot here on our interaction diagram, and we can see that indeed it is within our envelope solution here. So this is just another way to check your final design that you've done by hand using your interaction diagram charts.